Okay, let's get started on how to calculate page size. And I have a few problems here that we're going to go through. So, in page memory systems, the page size is determined entirely by the number of offset bits. So, if we have n offset bits, then the page size is 2 to the nth bits. So, we're going to use three different relationships. The first one is the page size, which is 2 to the nth byte. Then we're going to get the offset bit. Again, that's going to be 2. And then if we know the logical address size, which is M, and the page number bits, then normally we can get the N, which is M minus the page number bits. So the first one is a system uses 12 offset bits in its logical address. Again, this already tells us that N is going to be 12. And if we want to know the page size, we're just going to take that 2 to the power n. So that's going to be 2 to the 12, and that's going to come down to 496 bytes. And we know that 1 kilobyte is usually translated to 1024 bytes. And in order to get the full size, we'll take the bytes and we're going to divide that by 1 kilobytes. So we'll get that about 4. That's how you solve the first one. All right, so then for the second problem, we have a 32-bit logical address, and we can see that the offset covers the lower 3 hexa digits. Each hexa digit is about 4 bits. So if you have 3 hexa digit, and that's going to give us, what is it? 3 by 4, so we're looking at 12 bits. So for how many offset bits, we're going to get 12 from that. And 2 to the 12th power, again, that's going to be 496. And that's going to be the same thing as the above, which is 4 kilobytes per page. Okay, let's move to number 3. That says now we're told that the logical address is M equals 20 bits and the page number uses 10 bits, which is nice because we can get the bits by basically subtracting 20 from 10, and that's going to leave us with 10 bits and 2 to the 10th. It's going to be 1024, and that's going to be 1 kilobyte. All right, let's go to our last or second to last, and that is a system uses 4 kilobyte pages. First, we're going to have to convert our 4 kilobytes to bytes, and again, that's just going to go because 1 kilobyte is 1024, so we're going to multiply that by 4, and we get 496 bytes. To convert that to the power of 2, again, that's going to be what? To express this in the second power, that's going to be 12. So we're looking at 2 to the 12, which results in just being 12 bits. Again, offset's going to be 12 here. All right, let's go to the fifth problem, which is our last one. The logical address is 32 and the page number uses 18 bits. Again, to get the offset bit, you're going to subtract M and N. That's going to be 14 bits, and 2 to the 14th, that's going to be 16,384 bytes, and we're going to divide our bytes divided by 1024. That's going to get about 16 kilobytes. And that's how you solve this. The key idea here is that the number of offset bits always determines the page size, and once you know the n, the rest usually follows immediately. Hope this helps.